All right, so today we're diving deep into the world of Ludwig Boltzmann.
Oh, a fascinating choice.
If you're listening, you probably already know a bit about him, but we're going to try and really get into it.
Absolutely.
And we've got excerpts from this article to guide us.
A great starting point.
Yeah, so for anyone who needs a super quick recap, who was this guy?
Well, Ludwig Boltzmann, he was an Austrian physicist, 19th century,
Okay.
and he really revolutionized how we think about thermodynamics.
Thermodynamics, right?
Yeah.
Big topic.
Yes, it is.
Heat, energy, how they all work together.
Exactly. The science of how energy flows, how it transforms. It's the stuff that makes our world go round.
Right, like why your coffee gets cold, but also how engines run and power, all sorts of things.
Precisely. It's everywhere.
Yeah.
And Boltzmann, he's probably best known for his work on entropy.
Entropy, yeah.
This kind of tricky concept about disorder or randomness in a system.
Yeah, always increasing, right?
Always increasing in a closed system, at least. That's what the second law of thermodynamics tells us.
This is, I think, a really hard concept for people to grasp.
It is. It really is.
It feels so intuitive that things just kind of, break down and get messy over
Well,
time.
right, like your room.
But to actually pin that down to a law of physics,
Yeah.
that's a whole other thing.
It is. And Boltzmann was a key figure in figuring that out.
And to do that, he really championed this idea of the atomic hypothesis, right?
Absolutely. He was like, look, if we want to understand how heat and energy work on a big scale, we have to understand what's happening with these tiny particles called atoms.
But at the time, that was not a universally accepted idea.
It was wildly controversial. A lot of people still thought atoms were just a convenient fiction, a useful tool for chemists, but not actually real physical things.
Right. They hadn't been directly observed yet.
Exactly. So Boltzmann was kind of sticking his neck out there, going against the grain of a lot of established science.
So let's set the stage a bit for all of this. The article starts us off in Europe during the Industrial Revolution, a time of massive change, especially with steam engines taking off.
Steam engines everywhere.
Yes.
Powering factories, trains.
Yeah.
Transforming society.
Changing the world.
But as our article points out, even before people fully understood how these engines worked,
Right.
there was this huge drive to make them more efficient.
Make them better.
Exactly, to get more power out, to waste less energy.
Yeah.
And this really fueled the birth of thermodynamics as a science.
So thermodynamics really grew out of this practical need.
In a way, yeah. Trying to understand how to build better machines led to these fundamental discoveries about heat and energy.
So who were some of the key players laying the groundwork for Boltzmann?
Okay, so before Boltzmann, we have to talk about Sadi Carnot,
Carnot.
often called the father of thermodynamics.
The father, he was really into steam engines, right?
He was fascinated by them, wanted to understand how they worked, how to make them better, and even though he was working with this idea called the caloric theory,
Caloric theory.
which was this kind of outdated idea that heat was a fluid.
Oh, interesting.
Yeah, it was flowing from hot things to cold things.
Okay.
His work on the limits of engine efficiency
Right.
is super important.
So he basically realized that there's a limit to how much work you can squeeze out of an engine.
Exactly. No matter how good your design is, you're always going to lose some energy in the process.
Some energy's going to escape.
Yeah. And this laid the groundwork for understanding entropy, this concept that Boltzmann would really run with.
Okay, so that's Carnot. Who else is in this pre-Boltzmann crew?
Well, there's James Joule. He actually started out as a brewer.
A brewer?
Yeah.
Dang.
He was obsessed with measuring everything in his brewery.
Okay.
Temperature, pressure, all of it.
Wow.
And this led him to study the relationship between heat and mechanical work.
Okay.
He actually built these elaborate contraptions to measure how the temperature of water changed after churning it with paddles.
That's dedication.
Right, so much work just to figure out how much heat you generate by stirring something.
But that work led to what we now call the mechanical equivalent of heat, right?
Exactly, a fundamental principle in thermodynamics.
So measuring beer temperatures led to, a core discovery about energy. That's amazing.
It is. It's one of those great examples of how seemingly mundane things can lead to profound insights.
Okay, what about Lord Kelvin? Wasn't he in the mix too?
Yes, William Thomson, Lord Kelvin. He built upon Joule's work and came up with this absolute temperature scale,
The Kelvin scale.
the one we use today in science.
Right.
And this was huge because it gave a more fundamental way to define temperature, one that didn't depend on what substance you were using to measure it.
Okay, so we've got Carnot figuring out the limits of efficiency, Joule showing us the link between heat and work, and Kelvin giving us a better thermometer.
Right.
So where does Rudolf Clausius fit into all this?
Clausius, he was German physicist.
Okay.
And he, like Carnot, was really into the theoretical side of thermodynamics. And he's the one who actually coined the term entropy.
Okay.
And he gave a more sort of mathematical formulation to the second law.
The second law, which says that entropy always increases.
Yes, but what was really interesting is
What?
while Clausius sort of laid down the law, so to speak,
Yeah.
the physical meaning of entropy, what it really meant, remained this big mystery.
So all these pieces were in place, but something was missing.
Exactly, and that's where Boltzmann comes in.
Boltzmann, right, the star of our show.
He took these laws of thermodynamics,
Yeah.
and he explained them by starting with this assumption. Matter is made of atoms,
Atoms, right.
and their behavior can be understood statistically.
But, like we said, not everyone bought into the whole atoms thing.
Oh, no, it was a huge debate.
So Boltzmann's work was really built on these three pillars, right?
You got it. Thermodynamics, the atomic theory, and probability.
Okay, now the article mentions a pretty tragic event that happened early in Boltzmann's life.
Oh, yes, his father's death from tuberculosis when he was just a teenager.
Really young.
It had a profound impact on him, apparently.
It makes sense. I mean, losing a parent so young.
Yeah,
It kind of forces you to confront the randomness of life, right?
absolutely. And you can see how that experience might have led him to think deeply about chance and probability, these ideas that would become so central to his work.
Okay, so we have this brilliant but somewhat tragic figure entering the world of physics.
Right.
The article talks about his early career,
Yes.
rising quickly through the ranks at the University of Vienna.
He was clearly a rising star, mentored by Joseph Stephan, another big name in physics at the time.
We talked about him earlier.
And the article paints this picture of their workplace, the Institute of Physics on Erdberg Street.
Yeah.
It wasn't fancy or anything, but it was this vibrant hub of activity, full of enthusiasm and creativity.
Like a scientific startup.
Yeah, kind of limited resources, but a ton of intellectual energy.
So Boltzmann's surrounded by all these brilliant minds, soaking it all up.
And one of the key figures he meets there is Joseph Loschmidt.
Loschmidt, the absent-minded guy.
That's him. Brilliant, but always getting distracted.
Yeah, the article tells this funny story about him meticulously cleaning a piece of equipment
Oh, yeah.
and then showing it off to Boltzmann and saying, see, I've tried to extract from the fact that it's clean.
Classic Loschmidt.
Right, but for all his absent-mindedness,
Yes.
Loschmidt made some really important contributions.
He did. He was the one who calculated the size of air molecules and what we now call Loschmidt's constant.
Which tells us how many molecules are in a given volume.
Exactly. Crucial for understanding the behavior of gases.
So Boltzmann's learning, collaborating, and starting to develop his own unique approach to physics.
Right, and his early work focuses on the kinetic theory of gases.
Kinetic theory, meaning like how these tiny particles are moving and colliding with each other.
Exactly, building on the ideas of James Clerk Maxwell.
Another big name.
Oh, yes. Maxwell had already laid some of the groundwork, but Boltzmann took it further, connecting entropy to probability through this kinetic theory.
Okay, so if I'm getting this right, he's saying entropy increases because there are just way more ways for things to be messy than organized. Like shuffling a deck of cards.
Exactly. You're far more likely to end up with a random jumble than a perfectly ordered deck.
And to prove this point, he even calculated this thing called recurrence time.
Right, the time it would take for a system to randomly fluctuate back to its original state.
And that time is...
Huge, astronomically long, practically impossible.
So, even though entropy can technically decrease in tiny, tiny fluctuations, the overall trend is always towards more disorder.
Exactly. It's like the universe's built-in tendency to get messier over time.
Okay, this is all fascinating, but we've hinted that not everyone was on board with Boltzmann's ideas.
Oh no, he had his share of critics.
In fact, he faced some pretty fierce opposition, right?
Oh, absolutely. Things were about to get heated in the world of physics.
Heated? Well, I guess we'll have to save that for part 2 of our deep dive.
Yes, we'll explore those controversies and how Boltzmann's ideas ultimately triumphed.
Stay tuned. Okay, so we're back and ready to dive into some of the controversies that swirled around Boltzmann's work.
Buckle up, it's about to get interesting.
Because not everyone was thrilled with this whole idea of a universe driven by chance and probability, right?
Oh, definitely not. I mean, it challenged some pretty fundamental assumptions about how the universe works.
And some of the fiercest pushback actually came from people close to Boltzmann, like his friend and colleague, Joseph Loschmidt.
Right, Loschmidt, the one we talked about earlier.
Yeah, the absent-minded genius.
Who was brilliant in his own right.
Yeah, but when it came to challenging Boltzmann's ideas, He was all focus.
He came up with this thought experiment that became known as Loschmidt's paradox.
Loschmidt's paradox.
And it really shook things up in the world of thermodynamics.
Okay, so what was this paradox all about?
Well, basically, Loschmidt said, imagine if you could perfectly reverse the motion of every single atom in a system.
Every atom?
Every single one.
Okay.
What would happen?
Oh, no, tell me.
Well, according to the laws of physics, the system should evolve in reverse.
Okay.
Entropy should decrease, things should get more ordered.
So it'd be like unshuffling a deck of cards back to perfect order.
Exactly. And this seemed to directly contradict Boltzmann's whole idea of the arrow of time always pointing towards more disorder.
Right, like if entropy can just as easily decrease as increase,
Yeah.
wouldn't that undermine Boltzmann's entire theory?
It was a serious challenge, that's for sure. I mean, it seemed like a fatal blow.
So how did Boltzmann respond to this? Did he just throw in the towel?
Oh, no. He was a fighter. He came back swinging.
Okay, how did he counter this paradox?
Well, he basically said, look, while a decrease in entropy is theoretically possible,
Okay.
it's so statistically unlikely, especially in large systems, that we'd practically never observe it.
So it's like saying you could win the lottery 1,000 times in a row.
Right.
But the odds of that actually happening are so tiny
Astronomically small.
that it's essentially impossible.
For all practical purposes, yeah.
And remember that crazy long recurrence time Boltzmann calculated?
Oh, yeah, the time it would take for a system to randomly fluctuate back to its original state.
That time was
Mind-bogglingly huge.
way beyond the lifespan of, well, pretty much anything.
So Boltzmann argued that, yes, a decrease in entropy is possible, but the overall trend, the overwhelming tendency, is always towards greater disorder.
Okay, so Loschmidt's paradox, while initially a major problem,
It seemed that way.
it actually forced Boltzmann to sharpen his ideas and really strengthen his argument.
Yeah, it's a great example of how these scientific debates can push our understanding forward.
They force you to really think through your ideas and make them stronger.
Exactly. To address the weak points.
Now, Loschmidt wasn't the only one giving Boltzmann a hard time.
Oh, no, there were plenty of others.
In fact, the article mentions this whole other group of physicists who were really opposed to Boltzmann's ideas, the energeticists.
Yes, the energeticists.
And they were led by, you guessed it, Ernst Mach.
Mach, Boltzmann's philosophical arch-nemesis.
They really butted heads, didn't they?
Oh, they were constantly at odds.
So who were these energeticists and what did they believe?
Well, they were this group of physicists who thought we could explain the universe purely in terms of energy and its transformations.
Energy, but no atoms.
Right. They didn't buy into the whole atomic hypothesis.
Interesting. Why not?
Well, their big thing was that science should be based on what we can directly observe.
And at the time, you couldn't see atoms.
Exactly. So they were like, if we can't see them, they're not real.
It's a pretty strict viewpoint. If I can't see it, it doesn't exist.
It is, but it was a pretty common view at the time.
So Boltzmann was really fighting a battle on two fronts.
Yeah, on one side, he's got Loschmidt and his paradox.
Right.
And on the other, he's got the energeticists denying the very existence of the things he's building his whole theory on.
Talk about an uphill battle.
It was, but Boltzmann was undeterred. He believed in his ideas.
Now, all this talk about chance and probability, did Boltzmann ever try to apply these concepts to the universe as a whole?
He did, and it led to some pretty mind-blowing ideas.
Like what?
Well, he started thinking about what would happen if you let the universe just run its course for, like, an eternity.
Okay.
Given enough time, wouldn't it eventually reach a state of maximum entropy?
Right, that heat death we talked about.
Where everything's spread out evenly, no more stars, no more galaxies, just this kind of uniform, lukewarm soup.
Sounds pretty bleak.
It does, doesn't it?
But then Boltzmann throws us a curveball, right?
He does. He suggests that maybe, just maybe, our observable universe.
The one we see with all the stars and galaxies and stuff?
Yeah, all that.
Maybe it's just a statistically unlikely fluctuation.
A temporary blip in this much larger eternal universe that's mostly in this state of heat death.
Hold on, so he's saying our entire universe is just a random blip.
In a way, yeah, it's a wild idea.
So there could be other universes out there, other blips.
It's possible. That's what's so fascinating about Boltzmann's thinking. He opens up all these incredible possibilities.
Wow, so if our universe is just one of many possible fluctuations.
Yeah.
Does that mean the laws of physics could be different in those other universes?
It's a question that's still debated today. Some theories suggest that maybe the fundamental constants of nature, like the strength of gravity or the speed of light,
Right.
maybe they're not so constant after all. Maybe they vary from one universe to the next.
So there could be universes out there where, like, gravity is super weak or the speed of light is way faster.
It is a mind-blowing thought, isn't it?
Yeah, it really makes you question what's truly fundamental.
And this leads to a really interesting concept known as the anthropic principle,
Anthropic principle.
which basically says that the universe we observe,
Our universe.
it has to be compatible with the existence of observers like us.
Otherwise, we wouldn't be here to observe it.
It's kind of a circular argument, but it's still pretty profound.
Yeah, it's like the universe is the way it is because we're here to see it.
Exactly. And this idea, whether you agree with it or not, it comes directly out of Boltzmann's work.
So Boltzmann's influence went way beyond just thermodynamics.
Oh, absolutely. His ideas touched on cosmology, philosophy, even the nature of reality itself.
And the article mentioned that in his later years, he really started grappling with these bigger philosophical questions.
Yeah, he became increasingly interested in things like the nature of science, the limits of knowledge, the meaning of it all.
So he wasn't just a scientist, he was a deep thinker.
Absolutely. He saw connections between physics and philosophy.
So tell me about Boltzmann's philosophical views.
Well, he was a staunch materialist,
A materialist.
meaning he believed that the physical world, the world of atoms and energy, is all that exists.
Okay.
No supernatural forces, no spiritual realms, just matter and energy interacting according to the laws of physics.
So he's basically saying, forget about mystical explanations. The universe is a giant, complex machine.
In a nutshell, yeah.
And this led him to be pretty critical of metaphysics, right?
Oh, yes. He thought a lot of philosophical questions were just empty wordplay.
He didn't hold back.
But it's clear that he was deeply committed to a scientific worldview, one based on observation, experimentation, logical reasoning.
He was a true believer in the power of science.
Absolutely. And he even applied this scientific thinking to how he thought about science itself.
What do you mean?
Well, he believed that science progresses through a kind of Darwinian process where theories compete for survival based on their explanatory power.
Survival of the fittest theory.
In a way, yeah, the ones that best explain the evidence, those are the ones that survive and get passed on.
So he saw scientific knowledge as constantly evolving, being refined, even replaced as new evidence emerges.
Exactly, a very modern view of science.
Yeah, very different from the traditional view of science as searching for some kind of absolute unchanging truth.
Right, Boltzmann saw it as a dynamic process, always moving forward, always getting closer to a better understanding of the universe.
It's amazing how Boltzmann's ideas, what's considered controversial and even heretical, are now so central to our understanding of science and the universe.
It's a testament to his vision and his willingness to challenge the status quo.
So as we move toward the final part of our Boltzmann deep dive, I can't help but feel a sense of sadness, knowing how his story ends.
Yeah, it's a reminder that even the most brilliant minds can be vulnerable.
Boltzmann's suicide in 1906 was a huge loss to the scientific community.
It was. He was a true pioneer.
Sadly, he didn't live to see his ideas fully embraced and validated.
But his legacy lives on.
And his work continues to inspire and challenge us to this day.
Absolutely.
Now, before we get to the final chapter of Boltzmann's story, there's one more mind-bending concept we need to explore. The infamous Boltzmann brains.
Oh, yes, the brains.
Yeah, get ready, because things are about to get really weird. Okay, so we're back for the final part of our Boltzmann deep dive, and I'm still trying to wrap my head around this whole Boltzmann brains thing.
It's a wild concept, that's for sure.
Like, it sounds more like science fiction than actual science.
It does have that sci-fi vibe to it.
But it all comes down to Boltzmann's ideas about entropy and probability,
Yeah.
right?
Absolutely. It's like taking those ideas to their absolute extreme.
Okay, so remind me again, how did Boltzmann picture the universe as a whole?
Well, he imagined this vast, eternal universe, mostly in a state of heat death.
Heat death, right? Where everything's kind of spread out evenly and nothing much is happening.
Yeah, like a cosmic soup that's gone lukewarm.
Not very exciting.
Not really, but within this vast expanse, there's always the possibility of random fluctuations.
Fluctuations.
Like little pockets of order and complexity popping up briefly.
And he suggested that our observable universe, with all its stars and galaxies, might be one of these fluctuations.
Exactly, a temporary blip in this much larger, mostly boring universe.
Okay, but how do Boltzmann brains fit into this picture?
So the idea is that given enough time, like an almost unimaginable amount of time, these random fluctuations could theoretically create anything.
Anything.
Even something as complex as a conscious brain.
A brain.
Yeah, imagine a vast cloud of particles just randomly swirling around and Purely by chance, those particles happen to arrange themselves into a fully formed working brain, complete with thoughts and memories and everything.
Wait, so you're saying it's possible for a disembodied brain to just pop into existence out of thin air?
That's the basic idea, and it gets even weirder.
Weirder.
The paradox suggests that it's actually more likely for a single, isolated brain to form this way than for an entire, complex universe like ours to arise from a low-entropy state.
Hold on, you're telling me that a random brain is more likely than our entire universe, with all its galaxies and stars and planets?
It sounds crazy, I know, but remember, we're talking about probabilities over incredibly long timescales.
Timescales that are basically impossible to grasp.
Exactly, and in a universe that's infinitely old, even incredibly improbable things become, well, not so improbable.
Okay, so like, if you flip a coin for an eternity, you're bound to get a streak of like a trillion heads in a row at some point.
That's a good way to think about it. It might take an absurd amount of time, but given enough time, it becomes almost inevitable.
So these Boltzmann brains, they're like the ultimate cosmic lottery winners.
In a way, yeah, they're the result of these insanely improbable fluctuations.
But let's be real, no one actually believes that we're all just disembodied brains floating around in a cosmic void, right?
Right, the Boltzmann brain paradox is more of a thought experiment than a serious scientific theory.
A thought experiment.
Yeah, it's meant to challenge our assumptions and see where our current understanding of physics might lead to absurd or paradoxical conclusions.
So it's like a cosmic reality check.
Exactly, and in a way, it's been used to argue against certain cosmological models that predict a high probability of these brains popping up.
Okay, so if your theory leads to the conclusion that the universe is full of random brains, you might want to rethink your theory.
It's a good sign that something might be off, yeah.
Now, this whole discussion raises a pretty big question for me.
What's that?
If we're just temporary collections of atoms assembled by random chance, what does it all mean?
That's a question that's been pondered by philosophers and theologians for centuries.
But Boltzmann's work kind of throws a new twist on it, right?
I think so. He showed us that even in a universe governed by chance and randomness, incredible order and complexity can emerge.
Like our own existence.
Exactly. As unlikely as it may seem, we're here, proof that the universe can create amazing things through purely random processes.
So even if the universe is playing dice, sometimes those dice roll in a way that creates something truly remarkable.
I like that. It's a nice way to think about it.
Okay, so as we wrap up our Boltzmann adventure,
It's been a wild ride.
I have to say, I'm kind of blown away by the scope of his ideas.
He really pushed the boundaries of what we thought we knew about the universe.
From steam engines to entropy,
From the arrow of time to Boltzmann brains.
he covered a lot of ground.
He did, and his work continues to inspire and challenge us to this day.
Absolutely. So to all our listeners out there, keep exploring, keep questioning, and keep diving deep into the fascinating world of science and ideas, because you never know what mind-blowing discoveries await you just around the corner. And thanks for joining us on this Boltzmann Odyssey. It's been a real pleasure to share his story with you. And until next time, keep those brains buzzing. And